You're flying above Earth on the International Space Station at an altitude of 250 miles. You cast a glance out the porthole and your eyes widen in surprise. There's some kind of bright blue flash just above nighttime Europe. It's like there was an explosion of some strange substance there. Such a strange luminous event was spotted by a French astronaut from aboard the ISS. And it wasn't an explosion at all. It was lightning and was directed upwards. Until recently, this phenomenon was a kind of fairy tale among pilots. Scientists had heard their stories about lightning striking upward and about red and blue flashes at high altitudes too. But there was no definitive proof of the existence of these luminous events. But they do exist and are called sprites, elves, trolls, and ghosts. So how does ordinary lightning work? Masses of moist air in a cloud rub against each other and create static electricity. It would be almost the same if you danced in a wool sweater. It becomes charged with static electricity. And if you touch a metal doorknob, there's a discharge between your fingers and the door. There's your lightning. So a thundercloud builds up a strong negative charge. Sooner or later, a leader is born in the cloud. It's a bright thermo-ionized channel, or more simply, lightning. The leader moves toward the ground in steps of a few tens of feet, and it can accelerate to an average speed of 200,000 miles per hour. At that speed, you could make a trip around the Earth in just 7 minutes. But negative particles attract positive particles, and particles with opposite charges will tend to connect and compensate for each other. So, simultaneously with the negatively charged leader, the positive charge from the Earth begins its upward journey. The electric charge from the Earth connects with the negatively charged leader in one channel. This is when the brightest and loudest discharge happens. We call it lightning. It's this discharge that you hear as thunder. The main lightning doesn't strike from top to bottom, but from bottom to top. Yep, that is, the lightning is actually directed upward. It's as if the Earth is striking back at the thundercloud. And that charge can reach up to 30,000 amps. Your average wall outlet only has about 15 amps. And the record for the length of lightning is about 440 miles. That's more than the width of the state of Kansas. Meteorologists recorded such lightning in Brazil. It was a discharge between giant thunderclouds. And the longest lightning strike was recorded in Argentina. A single lightning strike there lasted 16.3 seconds. By comparison, you blink at 0.1 seconds. So we saw a regular lightning strike. The positive particles from the ground neutralize the negative particles in the cloud. But the cloud is still full of positively charged particles. They accumulate and wait for their time to create lightning. Once the charge reaches a critical point, the lightning cloud throws that charge dozens of miles upward. This is called a blue jet. It's exactly the same luminous event seen by a French astronaut aboard the International Space Station. The blue jets look like someone turned on a gas burner pointing upward. The positively charged blue jets neutralize at high altitudes with negatively charged particles, but people on the ground cannot observe blue jets. Thunderclouds obstruct the view, but they can be seen from an airplane. That's why, for a long time, commercial airline pilots were the only witnesses to this phenomenon. On board the ISS is also a great place to observe jets, as they are born at the very top of thick clouds and shoot dozens of miles upwards. But if you climb even higher, you can see this kind of bizarre lightning. It's a sprite. It looks more like a jellyfish. A cloud of red charge at the top and a bunch of little tentacles coming down. Now, normal lightning can have a temperature of about 54,000 degrees Fahrenheit, but you can touch a sprite with your hands. Unless, of course, you're afraid of a powerful electrical discharge. The sprite has about the same temperature as an energy-saving light bulb. All because sprites are born in the mesosphere. This is the layer of our atmosphere that starts at about 31 miles high. And it's the coldest place on our planet. On the ground level, where we live, the air is much denser. There are just more air molecules. They absorb heat from the sun's rays, and we feel comfortable. But the higher up we go, the fewer air molecules there are. At the altitude at which commercial airline planes fly, there's no longer enough air to accumulate that heat. You wouldn't even be able to breathe up there. That's why every airplane has oxygen masks for emergencies. And the temperature here is even colder than at the South Pole. In the mesosphere, there's almost no air, and the temperature here can be around negative 202 degrees Fahrenheit. And although the temperature of the lightning itself is high, in general, It's like if you poured a glass of boiling water into a huge barrel of cold water. The temperature won't change much. Sprites can only appear when paired with thunderclouds below. As a discharge occurs in a cloud, a sprite appears in the mesosphere. It tries to equalize the amount of charge in the atmosphere. So it's like these red flashes of lightning are trying to reach down to the thunderstorm. And a sprite itself can be as wide as the state of Massachusetts. And then there's a ghost. It can appear for the tiniest fraction of a second right after the sprite. It's a faint green glow, like an aurora. They were first discovered in 2014, and official confirmation by the scientific community only appeared in 2019. They're still poorly understood, but there's a hypothesis that ghosts have something in common with auroras. At least their color is green, and it may arise due to excited oxygen atoms. Sometimes we can spot trolls along with sprites. They look like pillars that support a sprite. It's a red glow at the end of the sprite's tentacles. The next moment, the troll releases a red streak down from itself. And if we climb even higher, we can see the elves. They only appear for 1 millisecond. It's a dim, flat glow that appears during thunderstorms in the ionosphere at an altitude of about 62 miles above sea level. Elves can be as wide as the distance between New York and Washington, D.C. Elves were first discovered during space shuttle flights in 1990. And these are pixies. They weren't discovered until 2000. Scientists observed bright, brief, luminous events for 20 minutes. Although they look like lightning striking inside a cloud, they have nothing to do with them. Pixies are smaller than 100 meters, which is about 330 feet. We shouldn't forget that any lightning is extremely dangerous for humans, and if you're caught in a severe thunderstorm, you need to leave its epicenter immediately. You can determine how far you are from the epicenter easily. The speed of light is much faster than the speed of sound. So, when lightning strikes, it takes a couple of seconds until you hear the thunder. So, you need to measure that interval. Lightning! Now count the seconds. Every second of thunder delay after lightning is about 1,150 feet. That's the distance a wave of sound travels in 1 second. So if the thunder delay after a lightning strike is 5 seconds, you're about 1 mile from the lightning. You can also tell if there will be a thunderstorm by the smell. The air before a thunderstorm seems unusually fresh. This is because the air currents bring in ozone molecules from the upper atmosphere. The same ozone protects us from harmful ultraviolet rays and transfers heat from the sun to the atmosphere. What we use to breathe is the oxygen of 2 atoms. Add 1 more and you get ozone. Ultraviolet light breaks down the 2 oxygen atoms and is absorbed by them. These broken atoms are then attached to the normal double oxygen atoms. When an ultraviolet beam strikes an ozone molecule, it knocks 1 oxygen atom out of the chain again. But ozone tends to regenerate, so the lost oxygen is reattached to other double atoms. But the ozone layer began getting damaged when humanity started emitting harmful gas into the atmosphere. Freon is to blame. It's the gas we were using in old refrigerators. The freon molecule contains harmful chlorine atoms. Ultraviolet rays knock this atom out of the molecule. Then that chlorine atom steals 1 oxygen atom from ozone, and we have a double oxygen molecule that can't regenerate and save us from the harmful ultraviolet rays. This causes a hole to appear in the ozone layer. The most famous ozone hole was over Antarctica, but when humanity banned the use of harmful chemicals, this hole began to recover. It's not that the hole will close completely, it will just return to the way it was before.
Uh-oh, a strong wind is blowing. Black clouds cover the sky. Thunder is rumbling and is pouring down with rain. A storm is coming, but you don't care. You're sitting in your apartment listening to music and typing something on your computer. You hear a thunderclap. Look out the window and see a heavy downpour, a tornado, and lightning flashes. You close all the windows and go back to the computer. And then, bam! It seems that lightning has struck near your house. Your laptop and all electrical appliances in the home go off. The light goes out. You get scared. At this moment, you hear a strange hissing sound. You see how, like a phantom, a round glowing ball of electricity flies into your house through a closed window. It penetrates your room, hovers in the air, waits for something, and then flies back through the walls. The lights turn on, and everything comes back to normal. You've just seen a real natural phenomenon called ball lightning. and you're fortunate to be alive after meeting it. This is a rare phenomenon. Ball lightning occurs during a thunderstorm in the form of a floating sphere. It can change color from blue to orange and yellow. It's the approximate size of a basketball, but can also be much more significant. This lightning makes a hissing sound and a pungent smell. Phew! The first records of ball lightning were made in 1638 in England. Then, a giant glowing ball flew into the church window. Since then, there have been a lot of evidence of how ball lightning got into houses and frightened people. In the 20th and 21st centuries, scientists actively investigated this phenomenon. They found out that half of the cases with ball lightning were just hallucinations caused by magnetic fields during a thunderstorm. But they couldn't wholly refute the fact of the existence of ball lightning. They agreed that this phenomenon existed, and once they even managed to record it. The phenomenon of ball lightning was caught in China. Researchers studied the behavior of thunderstorms in 2012 using video cameras and spectrometers. They saw an unusual lightning strike, after which the ball appeared. It flew horizontally about 33 feet and disappeared. The spectrometer showed that the ball consisted of silicon, iron, and calcium. If it's real, then what is its nature? There are several theories. Perhaps the ball lightning occurs as a result of a lightning strike on the ground. Oxygen and evaporated elements from the soil create a reaction in the form of a round clot of energy. This explains why the spectrometer in 2012 recorded the same calcium in the ball lightning as in the ground. Another theory says that glass can generate these balls. Atmospheric ions accumulate on the glass surface and create an electric field. Together with a lightning strike, this field turns into ball lightning. That's why there's so much evidence that the sphere flies into the building through the window. In 2016, scientists pointed out that a lightning strike on the ground created microwave radiation that can form into a plasma bubble. This floating electric plasma takes a round shape and hovers in the air for a few seconds. Earthquakes can cause ball lightning too. During ground tremors, flashes of light appear from the depths of the crust. It's like lightning that comes not from the sky, but from the ground. Some of these lights may look like floating blue spheres. In 2014, scientists studied earthquake lights and found that some rocks emit electrical discharges during seismic wave impacts. In 2006, researchers at a university in Tel Aviv created a laboratory to study ball lightning. They used microwave radiation to recreate a lightning-like electric charge. In 2018, quantum physicists made a complex synthetic magnetic field similar to ball lightning. Physicists, chemists, meteorologists, and other scientists have conducted research and laboratory experiments many times to understand the nature of this phenomenon. But so far, no one has succeeded. Other glowing balls are less dangerous, but still mysterious. In clear weather, you can see strange glowing lights away from cities, somewhere in a swampy area. Previously, when there was no electricity, people noticed these lights. They thought someone needed help. What if some guy is stuck in the swamp and shines a kerosene lamp to get seen? People went to these lights to help, but fell into the swamp, and the light either flew away or disappeared. Some records speak of several lights at once. They moved quickly and changed their colors. Many believe that these were some kind of mystical creatures that lured people into traps. But over time, scientists managed to uncover the mystery of this phenomenon. Bioluminescent fungi and algae grow in swampy places. Sometimes they glow with blue light and create the illusion of glowing lights from a distance. Also, there's a lot of plant material in the swamps: leaves, grass, mud, clay, and tree branches. These substances decompose rapidly in humid conditions and release methane. As soon as methane contacts air, it ignites. The flame flies over the swamp in the form of a burning ball. Mysterious lights appear not only in swamps. People see them in deserts or mountainous areas. Sometimes it's headlights from cars. In other cases, it's the signal lights of an airplane. But in many cases, the nature of such lights remains unknown. And now, imagine a huge ball the size of a small city. It's like a dome, covers a large area, and protects it from tornadoes and storms. This phenomenon is called the Delco weather bubble and is located in Delaware County, Pennsylvania. That's how it all started. In 1996, one of the strongest snowstorms of the 20th century hit the U.S. East Coast. It was named the Blizzard of 1996. It covered almost all of Pennsylvania, but in the small town of Delaware County, Delco for short, the weather was good. The storm raged around but didn't touch the city. Since that year, the locals have believed that an abnormal weather bubble protects their houses. However, there's no scientific evidence of the existence of this bubble. After the blizzard of 1996, there were several more storms in the area, and forecasters claimed some storms would also cover Delco. But contrary to their forecasts, the weather there was excellent. Strangely, there is no meteorological evidence of this. One of the residents decided to investigate this phenomenon seriously. He followed the weather forecasts, looked at satellite photos, and saw how the black clouds diverged around the city. It rained heavily in the neighboring towns, but not Delco. This seems like convincing proof. And the question remains, should we believe the locals? There's one scientific explanation explaining the nature of this phenomenon. Storms may weaken here thanks to the sea air that accumulates in the Delco area. The street and the city surrounding area are filled with this humid, cold air. It creates a sort of stabilization of the atmosphere, and when intense storms from the west collide with Delco's air, they lose a significant part of their strength. And it seems as if bad weather just bypasses the city. But there's another explanation, a psychological one. All the known information about the weather bubble came from the stories of residents. They see confirmation of this phenomenon and write about it on social media. Someone said that they'd seen a tornado pass by his house. Others claimed that the bubble had saved them from a downpour. People think that it didn't affect others if there was no trouble with their house. Imagine the TV says that a storm has started in your city. You look out of the window and see a clear sky, no wind and rain. It seems to you that the bubble has saved you again. Although behind you, a few hundred feet from your backyard, a tornado is raging and tearing the roofs off of buildings. But you didn't see it and wrote to the social network that Delco has saved your city again. In this sense, the weather bubble becomes more like a virtual one, thanks to the people who write about it.
Bright, colorful flashes of pink and green light up the sky. You're watching it from your backyard in Pennsylvania. That's not something you're used to, but it's very likely to happen more often in the near future as the northern lights are shifting south. Northern lights, or auroras, appear as a result of solar storms. The sun is a huge ball of molten gases that are constantly moving, so such storms aren't rare. Our star produces a huge amount of energy that goes our way. It travels as electrical charges at the speed of about 3 million miles per hour, no big deal. When all those tiny particles from the sun reach Earth's atmosphere, they give some of the energy to atoms and molecules in its upper layer. The atoms and molecules can't hold it and give it off as light. You can see it as spectacular auroras around the magnetic poles of the northern and southern hemispheres. If you were watching them from space, they'd look like large ovals. The brightness, colors, and shapes auroras take depend on the altitude where the lights are formed and what particles take part in the process. In the northern hemisphere, locations like Alaska, Canada, and much of Scandinavia normally get to see the brightest lights. The biggest solar storm ever was recorded in 1859, and it was so powerful that the northern lights were spotted in Cuba and Honolulu, and southern lights were seen as far up as Santiago, Chile. In latitudes like that of New York, people were able to read newspapers in the dark under those northern lights alone. If something similar happened today, it would have caused $1 to $2 trillion in damage. With solar activity and pressure from the solar winds increasing, the aurora belt's borders are currently shifting south. Solar activity goes in cycles, each of them 11 years long. We're now in solar cycle 25, which started in December 2019, and will reach its maximum strength between November 2024 and March 2026. So, geomagnetic storms will become stronger and probably even reach G5 levels. Those levels are their strength ratings. For you to see the northern lights south of the Great Lakes, a storm must be rated at least G3. G5 storms will be able to produce auroras that will even reach Florida. In case you don't want to wait for the sun activity to peak in 2025, Head north if you're in the northern hemisphere, or south if you're in the southern hemisphere. Auroras down there are known as the southern lights, or aurora australis. It doesn't have to be cold for you to see the northern lights, it just has to be dark. Auroras are active throughout the year. You can't see them from April to August in the northernmost parts of the world because it's light 24/7. It's also important that there isn't any precipitation or clouds in the sky. Those will block your view. Light pollution won't help either, so move away from any cities. Try to get to an elevation to maximize your chances of spotting the lights. They can appear in a whole variety of colors, including white-gray. The green-yellow part you're most likely to imagine while thinking of the lights is just the easiest to spot with an unaided human eye. Sometimes you might not see the lights at all, but your camera will still catch them. They might seem dangerously close to Earth, but the closest the northern lights ever get to us is 50 miles. For comparison, planes normally fly at around 6 miles above the surface, and that already seems like a lot. The distance from Earth defines the color of the auroras. When atoms giving us this spectacular show collide closer to Earth, you can see blues and violets in the sky. Green and red auroras are born further away from our planet. Earth isn't the only planet to have northern lights. Jupiter and Saturn both have strong magnetic fields, and scientists spotted auroras up there using the Hubble Space Telescope and the Cassini and Galileo spacecraft. It looks like Saturn's auroras are also caused by solar winds, but it's not so clear about Jupiter. Despite what you can often see online, the northern lights aren't going to disappear altogether. Once the sun passes its activity peak and becomes less active, both the northern and the southern lights will happen less frequently, but will still be gorgeous. Another beautiful, rare phenomenon is called the green flash. It happens shortly after sunset or before sunrise when the sun is almost entirely below the horizon, and the Earth's atmosphere bends and scatters light from it. People mostly spot it over the ocean. It can also be yellow, blue, or purple. About once a year, you can spot a rare firenado in the US. Fire tornadoes start when a strong wind picks up heat from a fire. They are made of a flame or ash. They're different from regular tornadoes because they don't start from cyclones. Firenadoes are about as tall as the Leaning Tower of Pisa. Unlike firenadoes, fire rainbows or rainbow clouds don't cause any damage at all as they don't have anything to do with fire. You can only see them when the sun is very high in the sky and its light is passing through ice clouds, so they're pretty rare. The rainbow halos are just as unique. Again, it takes a specific type of ice crystals in the clouds of the surface of the Earth to bend light from the sun into a perfect ring. The same thing can happen with moonlight. The only difference will be that the moon halos are usually white and sun halos can be rainbow colored. A white rainbow is another rare illusion, this time created by fog and water. Like a usual rainbow, it's formed when light is shining through droplets of water. It loses color because fog droplets are hundreds of times smaller than those of rain. A white rainbow is sometimes mistaken for a moonbow. You can spot this one at nighttime as the moon illuminates it. That's why it's not so bright. If you ever see an upside-down rainbow in the sky, that's a circumzenithal arc. It's not really a rainbow, but a kind of halo like those around the sun or the moon. This optical phenomenon is caused by ice crystals in the upper atmosphere. You have the best chance to see a circumzenithal arc when the sun is rather low in the sky. It happens super rarely, but it can rain without a single cloud in the sky. It's sometimes called a sun shower because it looks like the rain is falling straight from the sun. In reality, rain clouds are at a distance from that specific location. With sun rays being angled, the clouds become out of sight. Then, it takes just a little wind to blow the rain in your direction. If you ever travel to regions with high altitudes, you might see something called penitentes. Those ice spikes form only in a really cold and elevated environment where the air is dry. The sunlight turns ice directly into vapor instead of melting it into water. That's why these blades of snow and ice up to 15 feet tall start to pop up on the surface of the Earth. One of the rarest types of clouds is lenticular clouds that look like giant mountain hats. They're formed when moist air travels over a mountain or a mountain range, and gets into an area of turbulence. Volcanoes can produce bolts of lightning. They're formed in columns of volcanic ash through friction and static electricity to connect the positively and negatively charged particles. To understand how it works, you can rub a balloon across your hair or your feet across a carpet and then touch a metal doorknob. Once a year, just for a few moments, a waterfall in Yosemite turns into a fireball. In winter and early spring, two streams flow down El Capitan Mountain. In perfect conditions in February, when the sun is hiding behind the horizon, it gets into the right position to reflect off the wall and color the water into fiery orange.